a user account to run, right? We're running the logic user there, or even machine as well. Same we do in Kubernetes clusters. You can run any with the default account also. But again, we always suggest for security reasons, use your own service account to run your application. That's what we are creating here. Then we always know that applications cannot persist data by default. You have to apply external measures like shared disk, NFS disk, EBS backed volumes, standard storages, any kind of external things, so that your application data can persist, right? Even if container pods restart tomorrow, recreated tomorrow, you should not lose your Jenkins jobs or data or any application data, especially databases. For that purpose, we need persistent volume in case of Kubernetes. That we will create. And then deployment is a way of deploying application. There are multiple ways to deploy pods or containers in Kubernetes. Deployment is one of them. So we are going to use deployment, but you can also create a stateful set, daemon sets. What are these? Daemon sets we don't create for Jenkins. But yes, there are multiple ways of creating application and deploying them on Kubernetes. We are using deployment. So by creating these kind of workloads, you can ensure that yes, 1 instance, 2 instance, or 3 replicas, whatever you define in the deployment, you see that? So you can run your application in high availability mode. That is what deployment or stateful set do. So right now I am mentioning 1 replica, and generally we run Jenkins in 1 replica only. Why? Because running more replicas not supported by Jenkins itself. Because the master you cannot run in multiple replicas, because it will be inconsistency with the flat file structure of Jenkins. That's why, but yes, if your application support, you can run multiple replicas also to share the load. So this deployment will ensure always your 1, 2, or 3, whatever you mentioned, replica will running. Okay, that's what deployment do in Kubernetes. Auto healing that we call. Or you want to auto scale, that is again deployment you will create with auto scaling. So this is why we have, and to access your application in Kubernetes outside the cluster, you require a proper service or ingress controller, ingresses. So right now we are going to deploy load balancer service in this setup. It will create a load balancer in Google Cloud. So as a platform today, I am going to use my Google Cloud platform, and there I have already created a Kubernetes cluster. Do you see that? This is a cluster with 3 nodes. It is running here, and on this I can deploy any application. So this works like a platform for me. So you can see the details. The cluster name is DevOps. It is running in this region. It is running this version of Kubernetes engine. So I can connect to this cluster. This is the command. So this is Google way of connecting to cluster using Google Cloud CLI. But yes, to connect to any Kubernetes cluster, you just need Kubernetes config. So I can use my cloud shell. This is a ready-made shell provided in any cloud shell that we call. So it already has gcloud CLI installed. So I can just go here, and I can copy the command and execute here to connect to my Kubernetes cluster. Again, it is not copied. Okay, so what it will do, it is Google Cloud way of fetching the kubeconfig file. You see this one, and I need in any environment, I can even get this kubeconfig file and connect from any machine to this cluster. If it is public endpoint, of course, access should be enabled, right? So I am able to connect to this cluster, and you can see cluster info. Cluster info. So you can see this is what connect. I can see my so kubectl. If you see, I'm running. It is a command line utility for Kubernetes. So you can see the nodes are there. 3 nodes you can see from command line as well. Now what is our purpose? To deploy Jenkins like mentioned here. So these all resources that you can see, I have already placed them in a GitHub repository, and this repository I will share with you all as well, so that you can also practice. So please copy this repository. Okay, so you can see the repository is in your chat window. Please copy it if you want to try at your side as well. So I have already cloned this. If you see this repository, how you can clone this? Git clone and repository URL. You can clone this repository. This is already cloned in my case, so it's already there, and you can go inside this folder. Go to controller, and there you can see all your YAML files. Kubernetes resources we deploy through YAML files. Okay, so you can see all namespace YAML is also there. Service account we have to create. In service account YAML we are creating the role, permission, everything, and then deployment, volume, and service. So I can go and deploy each resource one by one. How we do that in Kubernetes? kubectl apply -f and the file name. You can deploy multiple files also together just by doing -f and the file name. Suppose after this I create service account. See, the 2 files I can create, or so you can see 2 resources are created, right? Or 4 resources, because service account has 3 resources. In one YAML, you can package multiple resources also. See, this is one YAML service account. It has 3 resources. First of all, you create role for permissions. Then you create the user or service account, and how you grant permission to. Okay, repeat. So I'm telling you, in Kubernetes YAML, you can put multiple resources separating by 3 dashes. Okay, one YAML file can contain multiple resources. So this file you can see has 3 resources. One, cluster role. Cluster role means in Kubernetes, role or cluster role is a set of permission. So what if you want to give any permission? This is called role-based access control. Here you are defining that this role, Jenkins admin, has permission to all the resources. Star means all the resources, and words means permission. What action he can do is star means he can do everything on every resource. He is Jenkins admin role. So this is just a permission I defined. I have not assigned it to any person or account yet. Then I create an account here, service account, with the same name or any other name you can create. And this is where by binding I tell this permission I am going to assign to this service account. This is called role binding or cluster role binding in Kubernetes. So you see that this is how you assign this role I am going to assign to this service account. API groups actually, Kushagra, in Kubernetes, all resources, there are a lot of resources, and every resource belongs to a particular group, which is called API group, because in Kubernetes itself is a microservice. That is all part of detailed discussion. But just to tell you, you asked a question. Kubernetes is a microservice application which is always accessible through APIs only. Now somebody can ask, hey, what are APIs? So again, these are different topics that we can't go into. But again, I tell you, Kubernetes always access all the components through APIs. So any resource that you access, deployment, service, pods, container, they have their APIs, right? So every resource belongs to their API groups. If this is null, that means it belongs to default API groups. You don't need to provide them. But if it is custom resource, then you need to provide to the API groups also here. That means which resource belongs to which API group, that is given here. Like if I talk about pods, they belongs to V1. So V1 is part of default. That's why I'm not mentioning it here. So I created 2 resources, namespace and service account. How you get the resources? Simple command, get namespace ns. You see all the namespaces, and your Jenkins namespace is also created just 2 minutes before, right? Similarly, you can see your service account same way. You can write full namespace or ns for namespace, and you can write same short form service account SA, or you can write full service account also. But the one thing you see here, you can't see your service account. Why? Because this resource I created in Jenkins namespace. How you see that? By putting namespace name as well. And there you can see your Jenkins admin service account is created here. You see that? So this one is by default created by Kubernetes, that we should not use for security reasons. So now I will deploy other resources. You can also deploy all the files in a directory just by doing -f and providing the directory path. It will deploy all the files in just one go. It is super simple. So you see how deploying an application in Kubernetes is very simple here. Just single line command. All the files written already. And I can go and check my Jenkins is running here. Get? You can see all the resources in a namespace as well. In Jenkins namespace, see? So it is starting the Jenkins pod. It is not ready yet. It has 1 container, and out of 1, only 1 is ready. Sorry, 0 are ready. So it is not completely up. we have to wait for it. Even service is not ready because we don't see external IP for load balancer. Load balancer is provisioning state. So you can put that again, and you can see your service is ready, but Jenkins pod always take time between 1 and 2 minutes. It is normal. So you will have to come and wait. You can put in watch mode as well. If I just want to see pod status, put pod, pod or pods, all will work, and I can put in watch mode. So you see that it will keep polling it for the status using APIs, of course. The moment the resource changes the status, I will be able to see it again automatically. I don't need to run the command again. That's what watch mode do in Kubernetes. So my application is deployed. It is just taking time to get ready. And with the load balancer IP, you can copy the IP and you can go here, and Jenkins, it runs on port 8080. You can see that here as well. In the service, you can see it is mapping port 8080. So you can use this port, and you can see now the application is ready. One containers are ready. It will be 100 seconds for Jenkins to come up. And if you want to access this application, it is accessible on your. And from this view, you cannot even say it is running on container, Kubernetes, or VM, because Jenkins is same. And that's what we ensure for users. It doesn't make any difference. I'm running on containers, VMs, or Kubernetes. Correct? And now I need the initial password. It is in this file. So either you can go into the container, get this file and get the password, or you can also check Jenkins pod log. How we can check logs? You can just do kubectl logs and the pod name. This is the pod name provided here. And you can see this is the log you can check here. And this is already dumping the password here that you can copy, or you can go into the container and cat here. Anyway, it will work. I have the password and I can just log into Jenkins for the first time. Simple. Now I can install suggested plugin. This is required. Why? You can customize also. When you install Jenkins, it is empty Java application. It has nothing inside it, even not a single feature. So that is why Jenkins suggests at least install some default plugins which will make your Jenkins functional. So Jenkins is having a lot of plugins to provide you features, and you cannot install all the plugins. If you have to run Java application, then you install Maven, Gradle or something. If you have to run .NET, manage them, install MS Build. Not every plugin is needed everywhere, but few plugins are basic like SSH, timeout. See these ones, workspace cleanup, folders, timestamper. They should be installed by default. For matrix-based authentication, this one, pipeline, Groovy, these all needed. So you should install them by default. So it will install quickly all of them. You can install more plugins later. That is part of detailed topic in Jenkins. So you see, after that, it will ask you to create your first user in Jenkins. If you don't want to use admin, you can skip it also. It's showing you that option here. And then save and continue. Oh. Now your Jenkins is ready to use, right? You can start using Jenkins. So our work is done. We wanted to install Jenkins on Kubernetes. We have done it. Now the next thing will be just additional. Try to run a job here. So I can go and create a new item. And then let's create a test job, freestyle. Okay. If you get this, sometimes in containerized Jenkins, you might face this error. So I will tell you solution of this error also. You have to go to plugins. You have to install one more plugin for security. So go to plugins. In the available plugins, you can find all the plugins here. So you can search for what plugin you need. Right now I need a strict Scrum Issuer plugin. Okay. So you go and install this. Again, if you see this error, retry. It will in a try 1 or 2 times, it will install it. So after refreshing, just try once again. Because if this works, then everything can be sorted out. Not yet. Really strange. It works in one or two try. But I'm sure it will work. Let's give some more try. It will work. Okay, so it worked. It is installing now. You can see that here. So it takes few tries because the authentication is broken. But after installing this plugin, we can fix it. You can go to manage Jenkins again. Once the plugin is installed, go to security. And just you need to enable this proxy compatibility. After this issue will never come. Okay. Now you try to create a job again. Best job, freestyle. Okay. And you see everything work like a charm. So that issue is permanently solved. And what I want to do, I want to just run a simple command just to see my Jenkins is working, right? So I just want to run a command hostname and save. This is how you create a simple job. Now, how to run a job? Just run build now. And the moment you run it, your job will be triggered. You see the job executed. You can go inside and see the output here. And it was successfully able to send you the host name. And host name in case of Kubernetes, it will be same as your pod. Where this job executed, it is same. It is because it ran inside the same pod. So that's about the Jenkins installation and execution demo. I hope you found it interesting and was able to share some knowledge. All the materials in the Git repo I already shared with you. So now is the time to move to third part. Right? And in third part, before moving to third part, let me ask you a question. After this strong demo or useful demo and explaining you a lot of things about DevOps job market and usefulness, let me see how many of you are willing to learn DevOps and put your time and effort to achieve career goals in DevOps. Please type yes in the chat window. If you want to learn DevOps, you want to learn from anywhere, any medium. But the important thing is you want to make career in DevOps. Then you can put yes in the chat window. Okay, great to see a lot of responses here. Thanks everyone. So if you want to learn DevOps, you don't need to go anywhere. You are here today at the very right place. As a Cloud Train, we are already here to help you with a great learning in DevOps and many other skill sets. So we have a very good course for you to learn DevOps, and that we call Cloud Train DevOps Instructor Live Training Course. And once you attend this course, this will help you getting proficient in DevOps skills and gain the required skill set for getting a DevOps job. I always say people, getting a DevOps job can be one goal to learn DevOps, but this is not the only reason. Learning DevOps can be due to many reasons that you want, right? You just want to know it as an architecture manager, architect, right? Or you just want to coordinate with other teams. You want to use it in your current skill set, right? So there could be any reason. But trust me, learning DevOps is going to make you a better engineer from day one itself. By the more and more tools you start adding in your skill set, you become more relevant to yourself and to the market. So what are the key features? And I told you, many even directors and managers have joined our courses. They join just to learn DevOps to manage their teams better way. So this training is very special, and this is going to be live training. Okay, these are the key features. First of all classes will be happening live. You get a trainer like me or someone who will be teaching you all the skill set in live classes, where you can ask all the questions. And of course, like today, you will not be on mute. you can ask directly with the trainer what doubts or questions you have, and you can clear them out right away. Then whatever material your trainer is referring, like the GitHub repository I shared with you, right? There will be many like this, PPTs, hands-on documents, everything we share with you every day for your future references. And the third thing, recordings. Live classes are good, but they will happen only once. What if you want to refer the content again in future? To revise it, to refer it, what trainer was doing here. For that purpose, we understand and record all the classes, and we share you your recordings every day at the end of every session. So you see, whatever content we are doing, we are providing you as in terms of lifetime access. Even after training, you will have access to these materials. After that, whatever you are doing, things you are learning, you must practice them as well, right? To gain confidence. For that purpose, we will be giving you a lot of assignments from basic till advanced level, and a lot of projects you will be doing with us. Total 10 mini projects plus one capstone end-to-end CI/CD pipeline will be doing all together. And once you are doing the stuff on your own, you are going through the content, revisiting the recordings, doing the assignments, you will get a lot of questions, problems, and doubts, right? So for that purpose also, we have Q&A arrangements in every session actually. So every session, because we are going to meet live for the live session, the first 15-20 minutes we keep for your question and answer. We sort your doubts from previous session first, and then we move to next topic. So that's helpful, right? And then a very special thing that we do in our trainings, interview preparation. So if other places, if you go for learning, you will need to pay for interview preparation. They sell you as a separate package. But in Cloud Train, we don't understand, we don't classify or consider this a separate package. Your interview is not a different thing. It is just your skill set, right? So if we are able to make you strong in your skill set from day one, interview will be like cakewalk, correct? So that's what we ensure here. So learning with Cloud Train is a lot of benefit. One is this reason, and the second biggest one is you learn from real DevOps professionals. So in other places, if you go, you will find full-time trainers. I don't say they are not good, but the biggest challenge with them is they never work in real-time environment. They don't get their hands dirty in production issues, troubleshooting, configuration, tools assessment. But as a real DevOps engineer or IT professionals, we do all these things on daily basis. So we are already coming with industry knowledge. So when we are teaching you, it already appears there, right? We are able to explain your topic from industry scenario perspective. And because of same reason, we are part of a lot of hiring and interview process also. And that actually, when we are teaching you, we ensure that from day one, topic one itself, we start covering important interview scenarios, questions, and we don't only discuss, we implement them as well with you. And that's where you start preparing for interview from day one. It's not a separate package here, it's included. And the last thing that you see, you will in the end, you will do a lot of assessments to just test your knowledge and see how your preparation is. So that's how this whole training is designed to give you most value. We have a lot of success stories. This number is continuously growing. Now we have 12,000 plus cloud trainees who we were able to help them to learn new skill set and move their career from one company to other. Few examples. This is very few examples, but we have many. Now coming to very important slide. What we do in this training. So on the screen, you can see total 10, 11 tools, right? So these are 10, 11 because we have total 11 modules in our curriculum explained, right? So these tools create the face of our curriculum, but we are not limited to it. As seen here, we are going to cover 22 plus tools in this training. Okay. The first you can see is introduction and prerequisites. Here itself, we start with 3 tools. What are these 3? I will explain you on next slide. The second is Git and GitHub. So there we cover version control system in detail of how we do versioning, starting from basic till advanced, right? Branching strategies, repo management, private public repos, security, branch protection rules, pull request workflows, branching workflows, right? Approval workflows, forking, collaboration, everything we do, merge strategies, merge conflicts. So these are starting from basic till advanced, all topics we cover here with details, with hands-on. But GitHub we also count as 11th tool here, you can see. Why? Because as part of version control system, GitHub is just providing you remote repo management. But it is not, that's it. It is just very small part of GitHub. GitHub is a complete enterprise tool which has its own DevOps. You know that? Like you have Azure DevOps, we have GitHub DevOps also. So under this DevOps training, actually you are learning all open source tools. And this is a superset of any DevOps categories you have. What we are doing is a superset. Any other DevOps categories you see, Azure DevOps, AWS DevOps, they are all just subset of it. Because if you know these tools, then learning any cloud DevOps or even doing it without learning is very simple. And one of them we are using here, GitHub DevOps. And do you know that GitHub DevOps and Azure DevOps are very similar? Why? Because they are both managed by Microsoft. GitHub was acquired by Microsoft in 2018. And since then, any feature that comes from open source, that comes to GitHub DevOps first, and then it goes to Azure DevOps. So directly, we are not doing anything in Azure DevOps, but by doing GitHub DevOps, we are taking you towards one step closer to Azure DevOps, right? Why we say GitHub is a complete enterprise tool? If you are doing Jira or ServiceNow today for agile project ticketing management, you can do that also in GitHub, project and issues. If you are doing Confluence for documentation, you can do documentation in Wiki itself, in GitHub. If you are doing Jenkins for pipelines, you don't need Jenkins even. You can do that in GitHub Actions. We do that in this training. So you see, we are covering even code scanning, quality, security scanning, code quality check, everything you can do, including container registry in GitHub. So it is a complete enterprise tool. We try to cover most part here, and that's why we call it 11th tool. Then for containers are very special today. They are new infrastructure. And that's why we spend enough amount of time here. 2 sessions on containers with Docker and 1 session on Kubernetes complete. And at least, and even you can see everything that you see here, almost everything you can run on containers today. We shown you Jenkins also today, right? So first session on the containers is very basic. We start with very basic so that you can understand from scratch how virtualization came, technology behind virtualization, how containerization came, technology behind containers. Then with Docker, we try to install container runtime, managing container lifecycle, security, configuration, resource management, everything we do here with Docker. But with every tool that you see here on the list, we also try to ensure that we make you aware about the other options, alternatives. Like with Docker, we have Podman available in the market, which is growing well now. Even containerd we do with Kubernetes here. So you see, these are not listed even in the curriculum, but these are a part of Plus. We do them. So we may not be doing them fully because Podman we don't do. But the moment I tell you, yes, Podman is 99% similar to Docker. So tomorrow, at least from this training, you know that yes, there is something Podman. If in tomorrow interviews, someone says, okay, we are using Podman, not Docker. In my organization, I will tell you we are using both. So somebody says, I'm using a Podman. Do you know Podman? If you have not heard the name even, you will be surprised, okay, what is this? But from this training, at least you have heard Podman is very much similar to Docker. Then you will say, okay, I have worked with Docker, I can work with Podman also. That's what HR or interviewer want to hear from you. Because they also know someone who does Docker can do Podman. The same we ensure, at least you will come to know what are the alternatives available, right? So, and then we start writing our own images with Docker, commit and Docker file. We prepare a lot of things there. Once you have your own images, you need to store them on container registry, right? We cover Docker Hub for that purpose in detail. That is again part of Plus. I'm even not counting it. So we do Docker Hub, but like Docker Hub, there are other options available. Every cloud has their own container registry. Do you know that? AWS has ECR, Google has GCR, right? So that is how, and let me tell you, they are 100% same. If you know how to log into Docker Hub container registries, you can log into anyone. Okay, so now you know that at least from this webinar also you know that, yes, this is possible. I know one and I can manage others as well. That's how I can tell you, even in my bucket, I can write 50 tools together. I know, correct? So this is how things work. Here, we try to make you learning and then aware as well about other alternatives because they are not complex. The second session on containers is more advanced. We talk about container networking, network drivers, storage drivers, volumes, bind mounts, and then these are all advanced topics, right? And then we talk about deploying application in multi-container environment. There we talk about linking of containers. Absolutely, we are moving towards microservices that we cover in detail. Then once you know microservices, we learn different tools to deploy microservices. Docker Compose, Docker Swarm is a container orchestration tool from Docker. And then we have biggest container orchestration tool, Kubernetes itself here. And to write your Kubernetes YAMLs, Compose YAMLs, GitHub Actions, Ansible playbooks, lot of things here and there. You require YAML and JSON knowledge that we also cover separately. Huge list actually. We cover more than required things. They are very much sufficient for you to prepare for any interviews or next role that you want. And then with Kubernetes, we are of course covering everything, how to create your on-prem. So first part we do on-prem cluster creation, how you set up your own Kubernetes cluster on your own machines. Learning master-slave components, RBAC, security, workloads, deployment, stateful set, ingressive services, everything we cover. And we cover both through GUI and command line. That's the thing, right? And then we go one step beyond again. In every topic, we go one step beyond. And we cover one cloud managed Kubernetes also. The one I shown you demonstration today, Google Kubernetes, we are going to do it in this training in detail, right? And then for the same reason, configuration management also, we have two tools here to cover. Why? Because there are two approaches, pull and push. We ensure to cover one tool from each approaches, again, to get you ready for whole market, not for just some tools. For security with Puppet, we do SSL, and for Ansible, we do through Vault. And if you remember this life cycle, there is a continuous testing stage, right? In DevOps life cycle. We want you to prepare for that as well. That's why we are covering one automated testing tool, Selenium, and we are using TestNG, learning to manage your test workflows and automated test results. And then we are doing Maven also for automatic dependency management build package of Java application. Of course, these three tools are not core DevOps tools. You might not need them tomorrow. But these are actually required to know some external tools so that we can do CI/CD in Jenkins in next session. That's how it is going to be a good learning. Then Jenkins, of course, we are going to do everything end to end. We cover all kind of installation. We start with the online VM-based installation. Then we also learn how to install offline, because any software installation you might be doing offline as well. In companies, for security reasons, we have servers behind firewall. And that is where offline installation will help you. This you will not find everywhere. Okay. And then container-based installation we also do. We do Kubernetes-based installation also, that we shown today. So you see, all possibilities we are able to share you because we use them on daily basis. Second, plugin installation. Again, online plugin installation was very easy. We saw that today in the session. But how you install offline without internet using HTTP proxy or download and upload. All methods we do. And in Manage Jenkins, whatever options you have, I will show you there are 17, 18 options. If you go to Jenkins, in Manage Jenkins, do you see? There are too many options. We cover all of them. That's too much actually. Nobody covers that. Including security, matrix-based security, authorization authentication, Active Directory integration, LDAP integration, we cover all of them. At least you will be aware that yes, this is there and how we can do it. It will not be something alien for you. And we also cover command line. Many of you might be knowing Jenkins is just GUI based, but you can do everything with command line as well, that we also do here. See, this is again additional. Then we learn all kind of agent nodes management, starting from VM based, container based, Kubernetes based, different ways of connectivities, connecting master to slave, connecting slave to master. All possibilities are there. Random port, fixed port, without port, WebSocket, username, password. So you will know all the methods that you can perform. And then we start writing automation jobs. We start with basic freestyle. We learn all kind of auto triggering of jobs. One job triggering other based on status. You are scheduling your job to run every hour, cron-based triggering, right? GitHub webhook triggering. Your developer is pushing new code on GitHub and it triggers the job here automatically, pipeline. And your Jenkins can also pull your repos to trigger jobs automatically. All possibilities. And then at the end, we learn pipelines. We start with build pipeline. We learn Groovy and declarative and scripted pipelines. We cover all. At the end of Jenkins session, we create end-to-end pipeline by picking all the tools together. And for monitoring, we have advanced tag, Prometheus and Grafana. And for infrastructure as a code, we have biggest tool, Terraform. Terraform can manage, this is just old number. This is growing every day. Even we have to update every time. It is now 3,800 plus tools and platform that Terraform can manage alone with infrastructure as a code tool. It is just not infrastructure now. It can manage almost everything, starting from every cloud platform, VMware, Kubernetes, Artifactory, even Google Drive and Gmail it can manage now. So you see, if you know Terraform, you can manage 3,800 plus tools and platforms. That's a big skill set. And companies know it. That's why HRs are looking for DevOps engineers, with Terraform knowledge. And of course, if you have this skill set, you become a crucial resource. You can manage multiple clients' environment and you get a better package. So this is how smartly this smart curriculum is designed by industry expert to give you best value out of this training. And here itself, I covered, in fact, 20, 21 plus tools, right?